Okay, let's go through this. So this is the term 1 class test in 2023 for the year 3. So this is the past year paper for year 3 WA1. Okay, 2023 version. So answer is C, D, B, C, B for the section A, which is the MCQ. So let's go through the answers. Okay, so let's start. They say under the same conditions, which gas diffuses faster than nitrogen? So we know that we are looking at rate of diffusion. If we're looking at same condition here, generally they are saying the temperature, no change. So how do you know whether something diffuses faster? There's actually only two factors. One is temperature, the other one is MR. So since temperature remains constant, temperature cannot be the factor affecting the rate of diffusion, then this has to be about the MR. So for nitrogen gas, what's the MR? Okay, nitrogen gas MR would be 2 nitrogens. Each nitrogen, so nitrogen is a 7, 14. So this is 2 times 14 here, the nucleon number at the top, so it's 28. So the MR of nitrogen is 28. Now let's find the MR for each of them. So carbon is a 612, neon is a 1020, sulfur is 1632. So carbon dioxide is 1C plus 2O. Oh, sorry, I need oxygen as well. Oxygen is 816. So this will be 1 times 12 plus 2 times 16. This will be equals to 44. Okay, 32 plus 12, 44. Carbon monoxide is 1C plus 1O. This will be 1 times 12 plus 1 times 16. This will be 28. Neon, just alone on its own. This one, the MR is just 1 neon. So actually this one is just 20. And last one, sulfur dioxide, is actually 1S plus 2O. This will be 1 times 32 plus 2 times 16. This will be 64. Okay, so therefore the answer here will be C, because neon, MR is 20, which is lower than 28. Next one, when the candle wax is heated, it softens and then melts between 62 to 64, so that you know that this is a range of temperature. Hence, what does it mean? That means there's not fixed temperature for melting. Okay, so this is what you can conclude based on what they mentioned here. So which of the statement best explain this? Particles of the wax move closer. This is definitely wrong, because actually if I'm melting, they are actually moving further away. So this is out. Particles in the wax move randomly at high speed. This is actually describing gas. So you know that it's melting, it only becomes liquid, so therefore B is out. C, wax is a pure compound. If it's a pure compound, it should melt at a fixed temperature. But then, no, it doesn't melt at a fixed temperature. It's actually over a range of temperature. So therefore, it is not a pure compound, it's actually a mixture. Therefore, the only answer left is D, is a mixture of different substances. Okay, that's for A2. A3, a new substance was discovered, a series of experiments was conducted on it. So which observation suggests that the substance cannot be an element? So we know an element cannot be broken down into anything simpler. Cannot be broken down into simpler. So which one suggests that the substance cannot be an element? Dissolves in water to form a colorless solution. So oxygen also can dissolve. Elements can dissolve in water. So therefore A doesn't say anything. Doesn't say anything. Okay, next. It forms 2 different oxides when reacted with oxygen. Element consists only of one type of atom. But then in this case here, it formed 2 different oxides. Most probably there's 2 different types of atoms. So actually, B is the answer. How about it having a fixed melting point? So fixed melting point tells you it is a pure substance. But pure substance can be a compound, can be an element. So it tells you that it can be an element, right? So therefore C cannot be the answer. Next one, have high density. Some elements have low density, such as your oxygen gas. But then you also have metals, which are like iron, which is high density. So this one doesn't tell you that it cannot be an element. It could be. So therefore A3 answer is B. Okay. Next one, A4. Elements M and N have atomic number 2 from 2 to 20. Okay, atom M has 8 more electrons than atom of N. So they say atomic number from 2 to 20, so it's from helium all the way to calcium. Okay. And the atom M has 8 more electrons than atom N. Okay. Student 1 say they are in the same period. Student 2 says they are says if they both form ions, both ions have the same charge. Which student should be correct? Now, if they're in the same period, okay, how do you know, right? So if you go and look at your periodic table, right, in period 1, there's only 2 elements. So if for them to be in the same period, they cannot have 8 electrons more. They only can be 2 electrons differently. In period 2, there's total 8 elements. So if I got 8 more, actually I'll jump to the next period, which is period 3, right? So realize that period 3 also got 8 elements. Then period 4 in the first 20 until 20, there's only 2 elements. So if I look at this here, if atom M has 8 more electrons than atom N, actually you realize that they will never be in the same period, because once I add 8 electrons, it must go to the next period already. Okay, so therefore student 1 is confirmed wrong. So this one is out, this one is out. So A cannot be the answer, B cannot be the answer. Next one. Student B say if they both form ions, they will have the same charge. So what you realize is that if let's say for example it is a lithium is a 3, right? Plus 8 electrons, actually they become a sodium, which is 11. If I plus 8 electrons, actually another one, potassium, is 19. So realize all of them, if they form ions, so lithium is 2,1. If I form an ion, it will become a Li plus because they will minus 1 electron. For sodium, it is a 281. I will minus 1 electron. So minus 1 electron, it will become an Na plus. For potassium, it is 2,881. If I add 1, if it will actually lose 1 electron. Okay, it lose 1 electron, it will become a K plus, right? So 2,881, lose 1 electron with K plus. So you realize that once they form ions, all of them will have the same charge. So therefore actually student 2 is correct. So answer is C. Okay, so do take note, this 8 more electrons here is actually the clue. So you think in terms of electronic configuration, once I got 8 more electrons, it must go to the next period. Then what you can do is actually for this question, you can use just take M as any one element, then you from there try to track what atom N is, then you from there can figure this one out. Okay, so in this case I use lithium as M, then actually N will be sodium. Or if I take sodium as M, K will be my N. So use examples that will actually help you to figure out this question better. A5. The diagram below shows the chromatogram of dyes X and dye Y. Some statements about the chromatogram are shown below, but let's look at dye X. Dye X only got single spot. Dye Y got single spot plus 2 other faint spot. So X looks like it's pure because there's a single spot. Y looks like it's impure because there's more than 1 spot. So some statements are shown. They say dye X is likely to be pure as contain only 1 spot. This is possibly true. X and Y are the same compound. Actually not true because Y actually has a 2 faint spots, so actually Y is a mixture. Dye Y is likely to be pure. It contains only 1 intense spot. Wrong. Intense spot doesn't mean anything. Actually what it means is you only want 1 spot. So I don't care whether intense or not intense, I just only want to see 1 spot. So it's only pure if there's only 1 spot. Therefore this statement is not correct. So not correct as well. Next one, the faint spot in dye Y are all less soluble than the intense spot. This is actually true because they travel a shorter distance. So if there's less soluble, they will be traveling lesser, travel a shorter distance, traveled a shorter distance, okay, in the solvent. So therefore, what you have is, this is statement 4 is correct, statement 1 is correct. So what's true about the chromatogram? Actually for this answer will be B, 1 and 4 only. Okay, next. Okay, so now let's go on to section B, B1. The table below shows some properties of solids A to E. Okay, so A to E here, soluble in water, no, yes. In terms of RF value, you can see here 0.90, 0.61, 0.53. These two don't have, most probably because it's not soluble in water. Next one, A is thermally stable, means you can heat it up, it won't decompose. Thermally unstable means it will decompose. Thermally stable here, sublime. Sublime means can turn from solid straight away to gas. Okay, so some methods of separating the mixtures as shown below. Select the most suitable method that can be used to obtain the underlying substance from the following mixture. So I want solid A from solid C. So A and C, one is soluble, one is not soluble in water. So actually, you can dissolve and filter. I realize down here don't have the dissolve part, no dissolve, no dissolution. So I cannot use the filtration without dissolving. So what is left here is between A and C is the thermally stable versus sublime. So if I heat up A and C, C will sublime and I'll be able to collect solid A. So therefore, what one answer is sublimation. Next one, mixture of solid B and water. So B is soluble in water. Okay. So if I mix solid B and water, actually I'll get a solution. So this is solution of B. B is thermally unstable, so I cannot use evaporation to dryness. Okay, so cannot use evaporation to dryness because it is thermally unstable. So therefore, the only way to obtain the solid B from the water is crystallization. So you say, can distill, I distill all the water out, left over is solid B. Cannot, because if you heat it too much, it's thermally unstable, it will decompose. So therefore, cannot also use distillation. Okay, so just think note. Next, I want solid E and water, but actually I want the water. So although E is thermally unstable, I don't care because all I want is the water, right? So therefore I can just use simple distillation. Okay, so this actually, if you mix solid E and water, actually you get a solution of E. Then what you want is to get rid of the water. So what you want is to collect the water, therefore you will do distillation, condense the water out. So that's why part 3 is distillation. Okay, B. An unknown sample is analyzed using paper chromatography with water as a solvent. The paper chromatogram showed one spot at 5.7 cm from the start line, and the solvent front is 9.3. Determine the substance that's present in the unknown sample, show your working. So first thing, find the RF value. So they know that 5.7 is from the start line to the spot, right? So therefore, this is the distance traveled by spot of the substance. 9.3 is the distance traveled by solvent. So you take one divided by the other, you get the RF value. So 0.61 or 3SF 0.610. So if I look at my table here, you realize B, the RF value in water is 0.61. So therefore the substance here must be B, since the RF value is the same. Okay, because this is all done with water as well. If I change the solvent, it's no longer water, then the RF value doesn't mean a thing already. Okay, RF value is only applicable to the substance in the same solvent. So just take note of that. Okay, next one, B part 2. A mixture of 3 flammable liquids. I got ethanol, boiling point of 78, isobutanol, boiling point 108 degrees Celsius, 3-hexanol, boiling point 135 degrees Celsius. So it's separated using the experimental setup here. I got fractionating column, so this whole setup is actually fractional distillation. Okay, so they say indicate and label the diagram of the direction of entering and exiting the condenser. So take note, the water always enter here, so water in from the bottom, water out from the top. Okay, so that's how you can label them. State the function of fractionating column. So fractionating column has all these glass beads here, right? It's actually to provide a large surface area for the vapor to condense on. Okay, why you want it is really to better separate the different components according to their boiling point. So why you want a large surface area for the vapor to condense? So you can better separate the different components according to boiling point. But the 1 mark actually goes to the parts in bold, so provide a large surface area for the vapor to condense on. So take note, that's the function that we're looking out for. State what modification I made to the fractionating column to ensure better separation of the mixture. So you can use the longer fractionating column, so have it longer for a greater distance for the gas to travel. The other one, use smaller glass beads, or you can use more glass beads as well. What you want to do in this case here is to increase the surface area for the gas to condense. Okay, part C. Explain why experimental setup used is not very safe in separating the liquid. So you can see this is a Bunsen burner, there's fire here. But what happens is that this liquid is flammable. So because the liquids are flammable, and then you're using a Bunsen burner, the setup actually may catch fire easily. So take note, this is an explain question. You can't just say flammable and you're using Bunsen burner. But say what's the problem with this. Is the setup may catch fire easily. Okay, if there's a leakage. So the flammability with an open flame, normally we won't do that. So this is the reason why it is not safe. Okay, next. D, they ask you to sketch the graph. So this is the answer for the graph. You also draw like that. 78 over here, 108 over here, 120 over here. Okay, so take note of the axis. So how the temperature measured. So I want the temperature measured by the thermometer varies against time. So when you see the word against, it tells you that what the word comes after that will be the x-axis. So time is on the x-axis. The thing before, which is the temperature measured, this must be on the y-axis. So temperature in degrees Celsius, take note, is a slash, then the units. Same thing, time here on the x-axis, slash, then the units. So labeling of graph, the axis labeling is important. So it's quantity, slash, then the units. Quantity, slash, then the units. Okay? Next one, because I want 25 to 120, so it's 25 here and then 120 there. So why is there 78 and 108? Because this is the boiling point of ethanol. Okay, so the temperature remains constant because ethanol is distilling out. 108 belongs to the isobutanol. So once all the ethanol is up, the temperature increases until it reaches here, where it reaches the boiling point of the isobutanol. Okay, then once all the isobutanol has been distilled, then the temperature will continue to go up again. If they ask you to extend some more, actually it will go up to 135. You will see it will become another step because this is the boiling point of the 3-hexanol. 3-hexanol. Yes, 3-hexanol. Okay, 3-hexanol is the name of another compound. Just take note, generally whenever it reaches the boiling point of the substance, the temperature remains constant for a period of time. So labeling of the temperature on the y-axis plus actually the x-axis plus time on x-axis, and the other one is correction of the graph where you're supposed to see two flat lines over here. Okay, two flat lines. Okay, so that's where the 2 mark goes to. Now B part 3. B3. The electronic structure of 5 atoms A, B, C, D, E are shown. So this is the electronic structure. Answer the following question about these atoms. Okay, each atom will be used once, more than once, or not at all. So first one, they say which atom, so singular, so I'm looking for one, has 13 protons. Because all of them are atoms, you know the proton must be equal to the electron. Okay, proton must be equal to electron. So if I want it to have 13 proton, means that it must have 13 electrons. So which one has 13 electrons? Answer is B. So 2 in the first shell, 8 on the second shell, 3 on the third shell. So therefore it's 13 electrons. Which atom is a noble gas? Noble gas belongs to group 18. So you actually have helium, 2. So 2 proton, 2 electrons. So configuration 2. The other one is neon, which is 10, 20. So this is actually 10 proton, 10 electron. Electron configuration 2, 8. The next one would be argon, 1840. So this is 18 protons, 18 electrons. The configuration is 288. So I look out for any one of them that has the 228 or 288. So you realize E is 28. So therefore that's neon. So therefore E is noble gas. Okay. Next one, which atom forms an ion with a charge of 2 minus? So 2 minus actually means that when it will gain 2 electrons to form ion. Okay. For it to gain 2 electrons to form ions, in general, this means that the outermost shell short of 2 electrons. Short of 2 electrons to be fully filled. Okay, so that's what you're looking out for. So this one here is actually 26. This is 283. This is 27. This is 281. This is 28. So actually you look at it, the one that is actually short of 2 electrons to be fully filled, answer will be A. Okay, because when A gain 2 electrons, it becomes 28. If we got a charge of 2 minus, it will be fully filled as well. Okay, B part 1. Complete the table below to show the number of electrons, neutrons, and protons for the following particles. So, sulfur 1634. So, this is an atom, no charge here. This one don't have, no charge. So, therefore, if I got 16 as a proton number, so I have 16 protons. Because the atom, 16 electrons. Then, to get neutron, it's actually 34 minus 16. Therefore, I got 18 here. Now, take note this S2 minus. So 16 here tells you the number of protons. 2 minus means that it has gained 2 electrons. So this one here actually is 16 plus 2 electrons. So therefore it's 18. Neutron is just the top number minus the bottom number. Nucleon minus the proton number. Answer will be 16 here. Okay, so take note, every 3 correct will be 1 mark. Now part 2. Sulfur 34 and sulfur 32 are 2 isotopes of sulfur. Use the information. They say use information, so you must code data. Okay? To explain what is meant by isotopes. So sulfur isotopes have the same number of protons. Okay? So how do you know the same number of protons? They have 16 protons, but different number of neutrons. So you know that sulfur 34 has 18 neutrons, sulfur 32 has 16 neutrons. So same protons, different number of neutrons. That's the definition of isotopes. Coding data based on this particular sulfur. Okay, so the part that I'm going to highlight is actually the coding of data, 16 protons. And the other one is saying that S34 has 18 neutrons, S32 has 16 neutrons. So the quotation of the data is important. So if you only just mention that the isotopes have same number of protons, different number of neutrons, that's just the definition, you get 1 mark. The use of data will be the second mark here. So just take note of this. Okay, so whenever you say use the information, reference to the diagram, reference to the table, that means you need to code the data. Okay? Next one, B4. Ammonia is a compound with melting point of negative 77.7 degrees Celsius. Boiling point is negative 33.3 degrees Celsius. It's manufactured by heating elements nitrogen and hydrogen at high pressure. State one difference between an element and a compound. So these are the two, okay, definitions. So just take note of it. Okay, we have gone through this in element compound mixture worksheet quite a fair bit already, so make sure you go and revise on that one. Next one, part 2. Draw the arrangement of ammonia molecules at negative 70 degrees Celsius. So I know that ammonia, they say melting point is negative 77.7. The boiling point is negative 33.3. So negative 70 is over here. This is negative 70. So this is the region where it is actually a liquid. Below is solid, above is gas. So negative 70 is actually liquid. So they're actually asking you to draw the arrangement of liquid. That's what they want you to draw. So what you should be looking out here is closely packed, but then disorderly arrangement. Okay? Take note, try to fill it up, and then make sure that it's not floating in mid-air. Okay, so 1 mark to make sure that you have these 2 points over here. Part 3. Using the kinetic particle theory, describe the change in arrangement and movement of particles as ammonia is heated from negative 90 to negative 60. So they want the change in arrangement and movement. So arrangement, how does it change? From closely packed and orderly arranged. So you can see here, arrangement, we got both packing and arrangement. Okay, whether orderly or disorderly. So you can see that's the first part here. So this is the first 1 mark. So change from closely packed to orderly, which is solid state. Okay, because negative 90, it is in solid. That's here. Okay, that's where negative 90 is. Negative 60 is actually over here. So you can see it's changing from solid to liquid. They're asking you from solid to liquid, what's the change? So closely packed and orderly arrangement is solid. Closely packed and disorderly arranged, that's for liquid. So say the solid arrangement, then say the liquid arrangement. In terms of movement, changes from vibrating in fixed position, which is the description of solid movement, to sliding over one another, this is the liquid movement. Okay, so you can see I'm just stating the solid movement, then others say the liquid movement, saying the change. Next one, using kinetic particle theory, explain why the temperature of ammonia remains constant at negative 33. So negative 33, you know that this is the boiling point. So why is it that when it's heated and then when it reaches boiling point, the temperature remains constant? So energy is absorbed to do what? Overcome the force of attraction between the particles. Okay? Now please don't just stop there, because energy absorbed overcome force of attraction. Then what's the problem here? There's no change in the average KE of the particles, or you say instead of being used to increase the KE. So you must talk about overcoming force of attraction, and then you must also talk about there's no change in the average kinetic energy of particle. Okay, so this one is actually 1 mark only. Okay, next one, B part 1. The diagram below shows an experiment to investigate the rate of diffusion for two gases, ammonia and hydrogen chloride. So I got the ring form here. You can see it's very similar to 2024 question. So they said distance travelled by each gas from the cotton wool to the white ring over here is measured and shown in the table below. So ammonia gas travels 60 cm, its relative molecular mass is 17. Hydrogen chloride distance travel is 40, relative molecular mass is 36.5. So then they came up with a conclusion. They say Max concluded a rate of diffusion is inverse relationship from the relative molecular mass. It means what? It means that when the MR increase, the rate of diffusion, let me erase this, rate of diffusion decrease. Okay, this is the inverse relationship. Okay, then so is Max correct? Actually Max is correct lah. John concluded the rate of diffusion is inversely proportional to the relative molecular mass of each gas. So actually this one is a bit of a mathematical thing that they are trying to test you lah, a bit on the mathematical side. When we say that it is inversely proportional, actually the equation would be when you take the distance travelled multiplied by the relative molecular mass, it will give a constant value lah. Okay, so it's a bit of a math thing. So you look at the answer here. So actually Max is correct. Explain answer, because as the relative molecular mass decreases, distance travelled increases. Okay, this shows that inverse relationship between the rate of diffusion and the relative molecular mass. Okay, so must quote the data from here, so take note. Okay, because they said using the information. Now if you ask me, actually I will improve on this answer, because if they want me to use the information, I will say that as the relative molecular mass decreases, I'll put from 36.5 for HCl to 17 for NH3. Okay, the distance traveled increase from 40 cm to 60 cm. So that's actually how you code the data. You must put the numbers in actually. Okay, this shows an inverse relationship between the rate of diffusion and the relative molecular mass. However, so this one now is trying to justify. So this for Max explanation, this for John. So they say for John, however, since the product of the distance and the relative molecular mass is not equal to a constant value. So you can see here it is the distance multiplied by the MR. It must give me a constant. Okay, but the problem is that this is not a constant, therefore you cannot use the term inversely proportional. So it's a very math thingy lah. So if you can look at it, for ammonia, if I take 60 times 17 is 1020, HCl is 40 times 36.5 is 1460. Okay, so take note, the key here is really the difference between inverse relationship versus inversely proportional. Okay. Next one, part 2. The original experiment is repeated, but this time the glass tube is placed vertically with the cotton wool soaked in the concentrated aqueous ammonia placed at the top of the glass tube. So instead of horizontal setup, they now place it vertical. So this is the new setup here for part 2. They say the distance travelled by the ammonia gas is found to be more than 60 cm. So you know that the top is ammonia, the bottom is HCl. Then they say that ammonia is supposed to travel 60 cm, right? But it went beyond that, so it went further down. So why is it so? you know that definitely if it's more than 60, it must have diffused faster. What could have caused the thing to diffuse faster? By turning it, actually you realize gravity has this, is now one of the factor that cause it to diffuse faster. So why ammonia diffuse faster is because it diffuses along with gravity, or it diffuses with the aid of gravity as well. Okay, so here gravity is the one that's helping it to diffuse faster. Okay, so that's for this one over here. That's all, everybody.